From the test, number 1. Let's see, do I have my key to this test or do I need to look at y'all's paper? I have a stack of keys. Yeah, I do. Look at that. Don't need to borrow anybody's thing to look at. All right. Number 1 is easy, but I guess we can do it. Number 1 from the test. Well, who the heck cares if you made a mistake? We're not worried about that. We want to worry about ones that you don't understand.
Well, I don't understand.
No, you just want me to do your work for you.
I don't understand where I made a mistake.
Exactly. You just want me to do your work for you. Yeah, and that I'll indulge on number 1, but we'll see what happens after that.
I don't understand the bottom problem.
I didn't understand number 5.
That may be true.
Or I guess I understood it. I just utterly failed. Remember.
You thought you understood it, but maybe you didn't. Okay, we're supposed to solve this substitution, so what should we do?
Substitute.
Try to find one.
Yeah, solve one. Which one would be the easiest?
Do that one. 'Cause that's one.
You're just like pointing at random stuff saying
top
that
one.
one. That makes sense. I agree. Let's subtract 5y from both sides.
Yay.
Wouldn't you do X?
No, because I'm going to solve for x, because he's already by himself, so that makes my life a lot easier. A lot of us did this on the test. This was, the majority of us got this step correct. It's then when we did the substitution that things started to implode for some of us.
I did do that.
I did too.
So, what should we do now?
Plug in.
Put that in there.
Yeah.
3, and this is right here is probably where it broke. You probably made a careless mistake in this space right here. Probably with distributing or combining like terms or something. There's probably some small mistake that you made in here that broke it. What should you do now?
Distribute.
No, definitely should distribute the 3. What's 3 times 3?
9.
9. What's 3 times negative 5y?
Negative 15.
That is so far on right.
Now what?
Combine like terms.
Where are they?
The Y.
15y negative.
Negative 17.
I see.
Then you add.
I made a basic.
You subtract 9.
Yep.
I added 9.
Okay, good. What else? Number 5? Okay, let's do it.
Don't forget the ordered pair.
Yeah, don't forget to write it as an ordered pair.
That's just.
I think most everybody understood number 5. I'm tempted to not even do it right now and let y'all find your own mistakes.
Understand.
No, I think you do. I think you just made a mistake.
But I don't know where I made a mistake.
I don't either.
Everything makes sense.
Well, you probably did made an arithmetic error. Knowing you, it was a negative mistake. You brought something negative when it should have been positive or vice versa.
But I checked for that so many times.
Sometimes if you're checking in the moment, this is very common actually, unfortunately. You'll make the same mistake over and over again because your brain will see it the same way every time. So probably that's what happened. For the D one, you should get negative 49 as your answer. The D sub X, should get 147 as your answer. The D sub Y, you should get 98 as your answer. And the D sub Z, you should get 196 as your answer.
Well, what's the D of X?
You should get 147. So that may help you zero in on where your mistakes may have been.
Just the D. So what's
What? 147 divided by negative 49, which is what? And then 98 divided by negative 49, which is what? And then 196 divided by negative 49, which is what? We can? Which one? I had several people miss that one. I think there was some sort of mistake happened. So from page 224, number 9.
we had someone do the payment,
Right.
that we did it sometimes.
Yeah.
It is. Plus 5. We're supposed to find the maximum or the minimum and the domain and range. So, probably, from what I could tell on the people that missed this one, you made some fraction mistake or negative mistake. So, I think you know what you're doing, but we can kind of walk through pieces of it. What do we do to find the x part of the vertex? We don't need that directly, but we need it to get the other part, right? So how do we find that?
Negative b over 2.
So negative 8 over 2 times 3, which is negative 4/3. So that's the x part, but that's not the maximum or the minimum, right? What do we do now? So to find us, is this going to be a maximum or a minimum? Minimum. Because a is positive, right? So we need to find f of negative 4/3.
Do you square the negative 4/3?
Yes, you do. And you would have to, one possible early mistake is you would have to do the squared before you did the multiplication. So you can't just cancel that 3. I don't know whether anybody made that mistake or not, but that is a mistake you could accidentally make. Even if you're in Algebra 2 and know what you're doing, you could just get in a hurry or whatever and kind of make a weird mistake.
I don't know what I was doing, but my problem doesn't look like that. We're on 9?
On the quiz, girlie. Page 224, number 9. It's like, I don't even know what I was way off. I didn't even have the same numbers.
Yeah.
So, 3 times 16 ninths
I think I did a negative wrong somewhere.
plus negative 32 thirds plus, just because we're going to want to do this in a minute, 15 thirds, right? We pre-reduce and get 1 and 3, and we end up with 16 thirds minus 32 thirds plus 15 thirds. 16 minus 32 is negative 16. So negative 16 thirds plus 15 thirds equals negative 1/3. And then you write the domain and the range and all the things. So probably just an arithmetic error on this particular problem, if you missed it.
I think it just went awful when I tried that step right there.
Yeah, you made some arithmetic errors somewhere.
Yeah, I think I just.
What else from the test?
The test was quick.
Test. Or the quiz,
Why
whatever.
did we both at the same time?
Because that's what people asked about. It's fine. You're going to be okay.
Good, everything I was doing, I just didn't do it very well.
This was easily the best I've ever had a class do this test.
Really?
We had some errors and stuff, but this, I feel like for the first time since I've been giving this stuff, pretty much everybody like had some clue how to do every type of every method. Usually I have a lot of people that are just like, yeah, I'm not doing that. I'll figure out elimination. Good luck to me. You know, whatever else. But I mean, even inverses I don't know that anybody was like completely off on inverses. So it's good.
I just matched one right.
Yeah, just some little mistakes. Frustrating.
So hard.
Just the little mistakes.
I didn't like that you talked about
Yeah.
the point per day.
Mr. Ordered Pair. Don't worry. Miss Units can console with you.
If I wrote the negative, I would have had the same score as these.
Sad.
In 2 spots.
Terrible.
I would have had a better score than this.
Okay.
See, why is it taking you so long to look at 4 numbers on my page?
Because I'm dying.
Okay. Let's look at 4-2.
On what?
The homework. Okay. It was so easy. I was scared the whole time I was doing everything wrong.
This lesson is stupid.
I thought so.
All right. Did we do like all the picture ones? Is that what we did?
1, 2, 3,
Yeah.
3,
Yeah.
14.
Yeah, that's good. All right. Number 1 is no real solution. Number 2 is -2 and 5. 3 is -4. 14 is -4 and 0. 15 is no real solution. 16 is 2. 17 is -2. 18 is no real solution. 19 is -3 and 4. Any questions on those?
I did the null set.
Yeah.
That's fine. That's fine.
That is it too. I'm just like so.
It's absolutely fine. Any other questions on those?
No.
We should do this next week too.
Next week, you're going to solve by factoring and look at complex numbers. And today, we'll practice both, because why not? We got lots of time. Factoring is something that you only get better at with practice. There are most things in algebra you can get the most better by understanding what it is and how it is. This, you just have to practice. This is like, if you've taken chemistry, this is like balancing chemical equations. The only way to get better at it is just to do it. Lots.
It's fun to do.
Okay. So, see what you remember from Algebra 1.
No. I just like to smash this.
Yeah. Okay. Well, and others. I need to look at what I'm about to assign you so we don't accidentally do any of your homework. That would be annoying. That would be so annoying. Yeah, I know. Y'all would just like get no benefit. Be so sad. Algebra 2. Homework that's due on 11/5. Lesson 4-3, 2 through 48 evens. Okay, as long as we stick with odds, we're good to go. Page 244. Let's do number 1 on page 244. We're going to write in a quadratic equation in standard form with -8 and 5 as its roots. So roots are kind of another word for x-intercepts, right? Also another word for zeros, depending on whether we're talking about picture or equation or whatever else, right? So that's what we're going to find. So here's steps for finding these. You ready? Step 1. Going to write it in a factored form. What do you notice? You mean the 8?
Yes.
Yeah. So the sign flipped from the zeros or the roots into the factored form. The signs flipped. Okay. So we just shoved it in here and then flipped the signs. Now this is not in standard form yet. Standard form is in descending order. Standard form of a quadratic is ax squared plus bx plus c equals 0. That's standard form. This is not in standard form. So how do we need to go about taking this and turning it into this form? Not really.
No.
It's already smiley faced.
Unsmiley.
Yeah, unsmiley faced, which is colloquially called FOIL. Yeah? We're going to multiply the first and the outside and the inside and last. Yeah. What's x times x? X squared. True fact. Good catch. X times negative 5 is negative 5x. 8 times x is 8x. 8 times negative 5 is negative 40. This is still not quite right. What's wrong with it? Got to combine like terms. Where are they? Negative 5x and the 8x. So the answer is x squared plus 3x minus 40 equals 0. Easy money. Y'all do number 3. Ready, go.
Why'd you laugh?
Because I've set you up for failure, which is great.
No!
Number 3.
Yes, sir.
Why did you make us do number 1?
Because I'm awesome like that.
Okay, I have set you up.
How do we do this?
Same thing.
But it's a scary number.
It's okay. Standard form can't have fractions as A, B, or C, so you're going to have to eventually get rid of fractions. I'm personally going to do this problem twice with 2 different methods.
The right one and the wrong one?
They're both right. One of them is just more forward thinking than the other. What am I doing? And just to be clear, decimals are fractions. So I don't mean change the fractions to decimals and then it's good. I mean, you need integers. Because I know that somebody is going to be like, I did change it to a decimal. Izzy, excuse me, sorry. Had something in my throat there.
Look at what you were doing. Yes, I didn't get those fractions. Hold on, how'd you get 15?
You have to times that by the common denominator.
Get 10.
Oh. But why is it on that side? I thought it was on the other side. Did I mix up the order?
You win.
No. Okay, so once you're finished with whatever you're trying to do, I want you to look up at what I did, and I want you to compare the ways I did it and see if you can understand the 2 different ways that I did, and then we'll go from there.
Wait,
Just be real.
It is. That was that noise.
Sean, say cheese.
Cheese.
I thought it couldn't be. I don't.
Which ones?
You understand?
I took the fraction.
Ish. Oh, did you already?
X times -5/2 with a 6 as a denominator.
Did you already change?
It seems to think that I've uploaded something, but it's still sitting there doing its own thing, so who knows?
Cool.
Yeah.
It makes so much sense.
Life makes sense.
This number is this with a 6 denominator. No. Well, I did the common denominator in my head, yes. So yes. Yes. Basically, yes.
Like you split up the fraction and put the denominator next to x, and then you did the FOIL.
Oh, I see.
Any questions about what's happening on the board?
No.
If you want to do fraction roots without dealing with fractions, this is the way to go. You put the denominators in front of the x's. The signs still flip. Or you can just do it that way and then get rid of the fractions later.
I like that.
Right? Both ways will get you there.
Interesting.
It's so much
Look how many
simpler.
steps less it took. A whole one step.
A whole one step. And I didn't even have to look at fractions and they stopped scaring me.
But you didn't flip the signs.
I did.
Wait.
Because the
Oh yeah, in the math book, yeah.
Yeah, from the original, yes. I didn't flip and then flip back. Okay. All right, we're going to do number 5.
Number 5.
Minus 3x.
we should just combine like terms and pretend like that's what it told us to.
You really shouldn't, though.
But like now I can't, right? Since it's written down.
No, you really shouldn't, though. Because there's an easier way to do this problem. How many terms are there? 4. Which means there's a really good chance that this can be factored by grouping.
You get everything divided by 3.
No, not right now. Because so you're actually kind of on the right track without even knowing it. Okay? So we can factor this by grouping. And what we mean by grouping is we group it into the front half and the back half. And we look at a GCF in the front half. What's in common in the front half? A 3 and what else? X. What's in common on the back half? 4 and only 4. There's no X in common, right? So 4. So when we factor a 3x out of the first 2, what's left? 6x, right?
Oh,
And then minus 1,
Oh, right now x.
right? 3x divided by 3x is 1.
Wait.
When I factor 4 out of the back half, what's left? 6x minus 1.
Where'd you do? Oh, the x was in back here. And now you distribute.
That would put it back to this. So no, definitely not. What do you notice about the 2 bits that are left?
They're the same.
They're the same. So now we've made it into this is a term and that's a term, so we can factor that out. We can factor out a 6x minus 1, and then what's left in the first one is 3x, and what's left in the second one is a 4. And now it's factored. Finite.
I'm gonna write that down now. I was too distracted.
Which you could have also done by combining like terms and then factoring the trinomial. You would get the same answer.
That's great.
But this is arguably less mental effort.
I feel like I'd make a mistake.
Well, maybe.
Wait, so what happened at the end? Just switch them.
No. I pulled a 6x minus 1 out of these and then wrote down what's left. So what's left in this is a 3x, and what's left in this is a 4.
What happens if the other two things aren't the same?
Then you did something wrong.
Okay.
Or it doesn't factor like that. Or more likely you did something wrong.
There's the more likely and there's the smaller.
Let's do 7.
7.
Yeah. Okay. Now what? We're supposed to factor it. Now there's 3 terms, so we can't factor by grouping. Now what do? We are going to do the smiley face. What's our first step there?
Parentheses.
2 sets of parentheses. That's true.
Parentheses.
Now what?
We put an X in the first part.
Yeah, because x times x is x squared, right?
Now you do something
Yeah.
with the 21 to make it eventually.
Yeah. We do something with the 21 to make it eventually. Yeah, that is true.
We find the possible.
What are the factors of 21?
7, 3.
7, 3, 2, 1, or 1,
Which one do we want to try?
7, 3.
That seems reasonable. What's 7 times 1?
7.
7. What's 1 times 3?
1.
1 times 3?
3.
3. Now, can we add or subtract those to get a negative 4?
Yes.
Yes. What do the signs need to be?
negative 7 and positive 3.
Follow our nose and follow our mouth. We got to double check the signs at the end. A negative times a positive is a negative, so it works. Right? We did it. All right, y'all should do 9. It's great. Sets you up for failure again. We love it.
Number 9.
Yep. Because in 9, A isn't 1 anymore, so it's hard. You are. Bless you, I think.
I think there was mice in here.
They can't be negatives, right?
There can be negatives.
I think I figured it.
It's not actually very hard. I'm making it stupid on purpose so we can see what's, I don't know, does it work?
It looks right, but I don't remember if that's how it works.
I think I did.
Is it?
Hold on, I'm gonna writing down.
How many shots did you have to do?
But I would have
Are we
probably.
not trying to get negative 16?
I
We
would've
are.
probably gotten it
You probably already found the
if
answer,
I
but
had remembered
I'm making a point. Did you already find the answer? Oh, you thought you did?
Why are you doing so many different
To make a point.
but like
But-
logic?
There's different ways of doing it.
No.
I didn't make this
None
up.
of those are correct. That's why they have the X. I think. Like, no, there's not.
He's showing the two ways of doing it, maybe?
I think he's showing you all the ways because they are things.
Oh no, how is it doing it?
What he did it?
Never mind.
It's literally. All he did was switch the 1 and 3, which doesn't matter. It's still 1 and 3 and the 4 is the same.
Okay. This is the right answer.
Yeah.
And the thing that I want you to remember is that when A is not 1, it isn't just X and X. That's the first thing. It's first common like mental breakdown. It's going to be something X and something else X. Not 1 on both of them. If A is not 1. So we can do 16 and 1, we can do 2 and 8, we can do 4 and 4 in this example, right? Okay, so also you might notice that I also was reminding you that the order matters and it changes, right? On this one, we get different numbers. So just because it didn't work with 8 and 2 doesn't mean it wouldn't work with 2 and 8, right? So the order matters when A isn't 1. And this is the right answer, so, you know.
The order
Should I
doesn't matter.
normally check it, the last one, something like for what you're trying to get them to do?
That's what it did. That's the check part. That's the blue part.
No, yeah, but like 1 times 3, but that doesn't, you know.
I don't know. I'm not following you. 1 times 3 gives us the 3, which is why it's 1 and 3. And it's always 1 and 3 because those are the only, on this one, because those are the only factors of 3. So it's always 1 and 3, but the 16 has multiple options. So yeah, there are lots of different things that you could try. And the more you do this, the more you'll be like, oh yeah, it's obviously 4 and 4. And then you try that and it's like, oh yeah, obviously, right? The more you do this, the more you don't have to necessarily try 500 different things.
You recognize the pattern.
Right. Yeah. Well, and you get to where you can kind of do a little bit of the arithmetic in your head, at least enough to kind of be like, okay, this is probably it. Let's go for it. And then whatever else. Okay. So y'all should do 11, 13, and 15. Ready, go. See if y'all can remember the last part of the problem or not. And actually 11 throws a slight curveball. It's easy, super easy. But if you don't remember what you're doing, then it's not, of course. If you get at all confused about what I'm writing at the board, you should like send up a flare and be like, but wait, what happened?
I don't know what to do.
You don't want to look. How did I know to do that?
The first part.
You always, pretty much, look for GCF first, always. Because even if it's a trinomial, it'll make it easier if you can pull something out to begin with. So always look for a GCF first to make it simpler. I looked. I give up. Make sure you understand what you're looking at if you do the looking. So remember, the part that you might not have remembered, once you have a thing completely factored and equal to 0, you can set each factor equal to 0 and solve those. So this would be a quadratic that opens up, that crosses the x-axis twice. At 0 and at 1.5, right? It's important that we keep a frame of reference on what we're talking about as we do it, but that's what will be going on here.
It's very narrow.
It is probably pretty narrow. You could figure out the vertex of it if you were wanting to, but you don't have to for this problem.
Oh wait, we're doing that. I just forgot it.
Excuse me.
Second placement doesn't have a GC. Unless you have one. Oh, they have an X now.
They do.
I think it's cheating.
The more of this you practice, if you are getting to the point where you're doing these equations and you can go straight from this to this, that's fine. You don't have to, if you can, instead of having to go x minus 9 equals 0 and then add 9 to both sides, if you go straight from here to the answer, that's fine with me in Algebra 2. If you do this, that's fine with me in Algebra 2. But we can skip that step if you can and want to. Just don't forget that the signs are happening. How you doing? Your face doesn't look like it's doing well. What's the matter? Who knows? Practice now. Practice on the video. Practice in homework. Practice, practice, practice.
with that?
We're not done. I just paused.
Oh, you're dividing by 2.
We're not really doing this yet, but we're not doing this yet, but to get you ready for later. That would probably be the most complete answer, but
What is that?
because it has a multiplicity of 2, which you don't care about right now.
I don't care then.
Later you care because it'll tell you things. And what it does tell you, you actually already know from the solving by graphing ones. This is a parabola opening up. I know it's, how do I know it's opening up?
You did them together, you did the 12.
What tells me this parabola would be opening up?
That it's squared.
No, that tells me it's a parabola. How do I know it's opening up?
It's
It's positive. A is positive.
what's
A is positive. So this, if this was y and we were graphing the thing, this will be a parabola opening up, and it just barely kisses the x-axis at 6.
He just did the
So we have one thing.
smiley. Why not write my 6 backwards?
Make sense? Good. Go away.
It's so like because when you time
Yeah, it's the thing, yeah.
it's 12 together.
Yes, makes sense.
Last year, I remember doing this.
I can tell. That's good.
I wasn't very good at it.
That means your Algebra 1 teacher did something useful in your life.